part 2 of our video, because of course we got cut off. All right, so you should have put that in your calculator. Final answer should be, hopefully y'all can see that, about 584.57 meters squared for our area. All right, example 2 right here. This is kind of weird. There we go. Okay, so each of these examples is a little bit different than the one before it. Like on this one, I gave you a side length. On this one, I'm giving you the apothem. Okay, so it says find the area of the regular octagon. All right, so first thing I always do is I draw that triangle. Okay, and then I also find that central angle. So in this case, we're doing 360, so it's an octagon, divided by 8, which gives us 45 degrees for our central angle. Okay, from there, I always draw the apothem. I basically just cut that whole thing in half. Now that's already drawn, so what I'm going to do is I'm going to draw that right triangle out to the side somewhere. Okay, apothem is 12. If I cut that 45 degrees in half, I get 22.5 degrees. All right, so think to your area formula. Area equals apothem times perimeter divided by 2. We have the apothem, it's 12. We need to find the perimeter, which means in my right triangle here, I need to solve for this side, right? Because that is this side of my polygon. So once I get that, I can basically double it, get a whole side, and then if I multiply that by 8, that'll give me my perimeter. All right, so we can do a little trigonometry down here. So you might want to write SOHCAHTOA. This is going to be a tangent problem, right? Opposite over adjacent. So I would say the tan of 22.5 equals x over 12. Okay, solving that for x, we multiply both sides by 12. So I'm going to rewrite that as x equals 12 times the tan of 22.5. Now, don't be so quick to get to your calculator. We're used to doing that. I'm actually going to have you guys wait on the calculator stuff. If we put it in the calculator right now, we'll have to round that answer, and then we'll end up having to round that answer another time. And by the time we get to the end, our answer is going to be a little bit skewed because we rounded so much. So I know it's a little uncomfortable, but I want you to leave it just like this right now. Okay, so that represents this side. Now what I'm going to do, and I'm careful every time I label this, x represents a half of my side. Now I'm going to double it to get the whole side. So instead of x, I'm now going to call it s for side. Okay, and I'm simply doing 2 times this whole thing. Now when you multiply all of this by 2, really the 12 is the only thing that gets multiplied by 2. So that becomes 24 times the tan of 22.5. Okay, so that is an entire side length. Well, now I'm going to take that and multiply it by 8 because that's going to give me my perimeter. So now I'm going to call it P for perimeter and take all that and multiply it by 8. Now, if you do that, 24 times 8, you get 192. So this becomes 192 times the tan of 22.5. Okay, now we have an expression for our perimeter. We know our apothem is 12. We can plug all of this into our area formula. Okay, so going back over here, my apothem is 12 times my perimeter, which is that long thing. 192 times tan, 22.5. And that's all divided by 2. Okay, so go ahead and put that in your calculator. I would put that whole numerator in, press enter, and then hit divided by 2 and press enter. And you should get, I'll reveal the answer here if you can see it anyway, it's kind of low on the screen, about 477.174 square feet. All right, example 3. This one's a little bit different than the other one too. It says find the area of the regular pentagon, but this time I give you the radius of the polygon. Still going to go about it in a similar way. So I'm first going to draw my triangle. I'm going to find that central angle. Oops. Okay, so we're doing 360 divided by 5, which gives us 72 degrees. All right, and then I'm going to immediately cut that in half. So I'm going to draw that right triangle out here. Okay, I'm going to label everything I can. Let's cut that in half so we get 36 degrees here. All right, so my area formula requires that I have the apothem and the perimeter. So I actually need to find both this and this so I can end up finding my perimeter. Okay, so pick one of them to start with. Let's just find the apothem. If we do the apothem with trig, we would be doing cosine because it'd be adjacent and hypotenuse. So let's write that out to the side. Okay, so my apothem is simply 17 times the cosine of 36, which I'm going to leave just like that. Okay, let's go ahead. I'll just make note. I'll circle that. There's my apothem. We'll use that in the end. Let's go ahead and find x right here. Now, if I do that, that looks like it's going to be sine, opposite over hypotenuse. Okay, so x equals 17 times the sine of 36. All right, now that represents half of the side length, so now I'm going to double that, and I'm going to change that to s for side. So that becomes 34 times the sine of 36. And then, now that I have a whole side, now I'm going to simply multiply that by 5, and I'll have my whole perimeter. So 34 times 5, we get 170 times the sine of 36. All right, so we have our apothem. We now have our perimeter. Let's plug that into our area formula. So we're taking all of this times all of that and dividing by 2. I'm going a little quick because I'm afraid I'm going to get cut off. This is what you should get. Area equals about 687.138 square inches. Okay, why don't you guys go ahead and try this one, the next couple. If you want to pause this and try it out, go ahead. I'm going to explain a little bit of it right here, a little bit about this. It says find the area of a regular pentagon inscribed in a circle with a radius 8 and apothem 6.5. Now, they don't give you a picture. You could draw one. Whenever I draw my pictures, I never draw the whole polygon because one, I'm not very good at doing it, and two, sometimes it'll be like a dodecagon, and there's just no reason to draw that. So what I usually do is I kind of just draw like what the bottom of a polygon would look like there'd be a bottom of a pentagon. But I seriously draw that same figure no matter how many sides it is, because it really doesn't matter. It just gives me a visual. So that's like the bottom half of my polygon, and then I draw one triangle in it. You really just need a triangle to solve these. There we go. Good enough. Okay. So they tell me that the pentagon is inscribed in a circle. There's nothing really remarkable about that because all these polygons could be inscribed in circles, right? So I don't need to draw a circle. And that just helps me figure out this is my radius. But we've already talked about that, so we know that is my radius. Apothem is 6.5. You guys go ahead and find the central angle, cut it in half. There's several ways you could solve this. You could do Pythagorean theorem. You could do some trig. Pause this, solve it however you want. I'm going to reveal the answers right now. Okay. Kind of weird how I have a few different answers. If you did Pythagorean theorem, you get this. If you did trigonometry with sine, you get this. And trig with tangent, you get this. I don't like that all these answers are a little bit different. I mean, they're pretty close, but they should be the same or very, very close to the same. So this was kind of a weird problem. And I think that's because this apothem, whoever made this problem, is rounded. It's not exactly 6.5, so that affects your answers over here a little bit. Okay, y'all can pause this and try number 5. I'm just going to reveal the answer right now.